Welcome to Lesson 2.5, the unions and intersections of figures. So obviously today we'll be looking at two big ideas, the first being unions and the second being intersections. So to start with definitions, the union of two sets, so if our sets are A and B, it's written as the union of A and B. So this big capital U is the symbol for union. And the union of sets A and B is the set of elements, so it could be numbers, could be data, whatever it is, set of elements that are either in A or in B or in both A and B. So our union we can think of as the word or. What is in A or B or both? Then we have the intersection of two sets. So again, if we're dealing with an intersection of two sets, A and B, it's written as the intersection of A and B. So if we flip the union symbol upside down, we end up with the intersection symbol. So the intersection of sets A and B is the set of elements that are in both A and B. So for an intersection, it's and. It has to be in both A and B. For a union, it's one or the other or both. So if we look at two images using Venn diagrams, in our first one on the left here, we have sets A and B. So the intersection of A and B would just be the section of elements or data that's in both A and B. The union of A and B, so our union of A and B, would be all the data in A, all the data in B, or in both. So that would include both full circles. So when we're looking at this idea of unions and intersections, most likely you'll be applying it to different geometric figures. So in this case, we'll be looking at this line, MR, with the point N between M and R. So both A and B are based on this line. They first want to know what is the union of ray MR, the intersection of ray MR and ray NM. So what is the intersection of ray MR and NM? So what I'm thinking is what points or what data is on both. So first off, we just have our line, MR. Then if I think about ray MR starts at M, goes toward R forever. Ray NM would be starting here at N, going toward M forever. So if I drew that on its own, it'd be this part right here. So where do these two pieces overlap? Well, they overlap from points M to N. So what's included on both would be anything in segment MN. So we would write our answer as the intersection of ray MR and MN would be segment MN, because that set of data, segment MN, is included on both. In B, we're looking at a union, and the union of ray NR and ray MN. So our union is what's on one or the other or both. So first we would think about ray NR, starting at N, going to R forever, and our other ray of MN, which would be starting at M, going toward N forever, which would continue to R and forever. So in that case, what points are on this first piece, second piece, or both? So the union of ray NR and MN would be the ray MR, because our ray from M to R would contain all the data that's on one or the other or both. Then we look at the idea of unions and intersections related to coordinate geometry. So remember, coordinate geometry is when we're dealing with a coordinate plane, so lines, intersections, different coordinates, x, y values. So when you solve a system of equations or inequalities, that's when you're applying the idea of unions and intersections. So the union would be all the points that are on both lines. So in the past, in algebra, when you had to plug a point into two equations to see if it was a solution for the system of equations, that is looking at the union with all the different points on both lines. The other concept with coordinate geometry that we have is the intersection. The intersection is simply put the solution or the point where the lines intersect. So when you figure out where two lines intersect in coordinate geometry, you're applying this idea of intersection. And then we can also apply unions and intersections to polygons. And next lesson, we'll be diving deeper into polygons. So the idea of unions and intersections in polygons is the fact that it's convenient to describe shapes using that idea of unions and intersections. For example, this triangle ABC over here could be represented using unions and intersections by saying the triangle is the union of segment AB, BC, and CA. So the union of AB, BC, and CA, the union of those three segments, is triangle ABC. Then we have the intersection of two lines, line segments, arrays. When a set of points contains just a singular point. So if they intersect at just a singular point, typically we write all of our sets in these braces or curly brackets. If it's just a single point, we can drop the braces or curly brackets. So a way we could write that would be in triangle ABC, we could write the intersection of segment AB and segment BC is point B. So you could write it inside the brackets, which would be contained in the set. It also would be this part over here, AB intersection BC. We could drop the brackets and write it as a single point B. So in other words, segment AB intersects segment BC at point B. Both of these would be read the same way. Then we move into the idea of a null or empty set. So if the sets have no elements, it is called a null or empty set. So this set is written as an empty set of brackets or curly brackets or a zero with a backslash through it. Both of these represent the idea of a null or an empty set. So if two figures have no points in common, their intersection is a null set. So in symbols, this situation over here at the right could be written two different ways. The intersection array FL in segment MN is the null set with nothing in it, or the intersection of array FL and segment MN is the zero with the backward slash. Both mean an empty set, meaning they never intersect. Now for example 2, there is a colored version of this subway system, the Washington, D.C. subway system on page 85 in your book. So if you want a colored version, it makes the different lines easier to see. So I'd pull out your book and open to 85 for this example. And in the subway system, we're letting R be the red line, B be the blue line, G being the green line, O being the orange, and Y being the yellow line. So each letter is representing that colored line in the subway system. So question A says, what does R union B, union G, union O, union Y mean? Well, it's the union of all the lines. So that would mean it's the entire subway system, because the entire subway system would be the union of all the different lines. In B, what does the intersection of the orange line and green line mean? So it's asking us, where do the orange and green line intersect? So if I find my orange and green lines, they intersect here at La Infante Plaza. So the answer to that question, the intersection of the orange and green lines, is La Infante Plaza station. So they intersect at that subway station. And then we have C. What does R union B union Y mean? It's the union of the red, blue, and yellow lines. So that would mean it's the entire system except the green line and the orange line on their own. So it includes the red, blue, and yellow lines, leaves out the green and orange. And then moving into our final two examples for today. Example 3 has to deal with first you drawing a convex four-sided polygon. So in this case, I just drew basically a parallelogram ABCD. You could draw any four-sided polygon or quadrilateral. Make sure you label your vertices in order, so A, B, C, D. So now question A is asking, what is the union of first the whole polygon, so the union of polygon ABCD, which would just be our perimeter, the union of segment AC, which we didn't have drawn, but it would be this diagonal here, and the union of BD, which is this diagonal. So really what that would be all the endpoints or vertices plus the segments and diagonals. So what is this union of where these all are included? So of polygon ABCD, side AC, union side BD. That would include our vertices ABCD. It would also include any points on AC and any points on BD. So our union in this case would be segments AC and segments BD, so including the four endpoints plus those segments would be the union. In part B, polygon ABCD intersection, and then in parentheses, we have AC union BD. So first the polygon ABCD, so our perimeter again, and then the union, then the intersection of the union of segment AC and BD. So first, what's on AC or BD? So AC and BD would be our diagonals plus their endpoints. Where do those intersect with the polygon? They intersect only at our four corners or our vertices. So that answer, our set, would just be points A, B, C, and D. Then example 4. Example 4 is asking us to draw different Venn diagrams for each of the following situations. So we have in part A, the intersection of set A, B, and C. So A intersect B intersects C. So what part is on A, B, and C would only be this little section here where all three overlap. In part B, it's the union of A, union B, union C. So we're wondering here, what's the union of these three circles? So that would be all the points in each of the three circles or that they share. So our entire Venn diagram. In C, they're asking first, the union of AB. So the union of AB would be anything in A or B or both. So we know it includes the top. And then the intersection of that with C. So what's in A or B and C would just be these three little sections where A, B, or both intersect with C. And then in part D, what is the intersection of A and C? So we don't care if it's in B or not. We just care about what's shared between A and C. So it would be these two sections where A and C overlap. But going back to the main idea of this lesson, it can all be boiled down to the idea of unions and intersections. And unions are what are in one set or the other or both. Intersections are what is contained in both sets or what's shared in both sets.